I'm going to explain the condition for the line y is equal to mx plus c to be a tangent to an ellipse x square by a square plus y square by b square is equal to 1. Let P be a point on the ellipse, so it's the coordinates x1 comma y1. Since it's a point on the ellipse, it should satisfy the equation of the ellipse. So you can substitute for this x, x1, for this y, y1 square. You know the equation of a tangent at the point x1 comma y1. Equation of the tangent is x1 by a square plus y1 by b square is equal to 1. Where there is x square, you have to write xx1. Where there is y square, y1. Then you will get the equation of the tangent. Now let us rearrange this LCM of this a square b square. When this is divided by a square b square, so b square xx1 plus when this is divided by b square a square y1 is equal to 1. Take this to the other side, so you will get this equation. Now you rearrange this equation. A square y1, this you take to the other side, so it will become minus b square x1 x plus a square b square. Our aim is to determine the condition for this line to be a tangent. That means these two equations are representing the same lines. So coefficient should be proportional. So here coefficient of y is a square y1. Here coefficient of y is 1. So a square y1 by 1. Here coefficient of x is minus b square x1. Here coefficient of x is m. Here constant term is a square b square. Here constant term is c. Now y square, from these two you can get to y. You can get to y. This a square will get a square will get cancelled. So y1 is equal to b square by c. Equating these two, you can get y1. Equating these two, you can get x1. So now x1 is equal to a square. Then this b square will get cancelled. Then this m will be taken to the numerator, the other side. Then c. Then this minus is taken to the other side. So x1 is minus a square m by c. Now we are getting x1 and y1. That you substitute in this equation. x1 square is there, so square of this. The square of this is a raised to 4. When you square, negative will become positive. Then m square, then c square, then this a square plus y1 square. So y1, this is y1, so it's a square, so it will become b raised to 4. It's square c square. Then this b square is equal to 1. Here you can see c square common, so you take to the other side. C square common denominator, c square is in the denominator common, so you take to the other side, so it will become c square. Now a raised to 4 a square, so it will become a square, then m square plus here b raised to 4 b square, so after cancellation it will be b square. Then this c square taken the other side. So now we are getting c square. Then for getting c, you take the square root. When you take the square root, you would write plus or minus, then square root of this. Square root of this is a square m square plus b square. So if the line y is equal to mx plus c is to be a tangent to the ellipse x square by a square plus y square by b square is equal to 1, the condition is the c should be equal to plus or minus square root of a square m square plus b square. Then here for c, you can substitute this plus c, you can substitute y is equal to mx plus c. For c, we can substitute this plus square root of a square m square plus b square. or you can substitute this negative value minus square root of a square m square plus b square. Either y is equal to mx plus c, square root of a square m square plus b square will be the equation of the tangent, or y is equal to mx minus square root of a square m square plus b square, but not both. Any one of this will be the equation for the tangent, but not both.